All right, section 1.4. If I say the word sequence, what does that mean to you?
How many numbers is skipping?
Pattern, what did you say?
How many numbers is skipping?
How many numbers it's skipping, okay? So here we have a sequence, and I want you to find the next two terms. How do you find the next two terms?
You subtract 5 from one, and you subtract 5 from everything, and then, yeah.
We want to find the pattern, right?
Yeah.
Which is, I think, is what you said.
Find how many is in between.
Right. How do I get from 1 to 5?
4. Plus 4.
Add 4, 5 to 9.
Plus 4.
9 to 13. Add 4, 13 to 17. Add 4. So what would my next term be? 21. Add 4 to get 25. Good. So we are going to be working with sequences today, and we're going to be putting them into recursive and explicit definitions. But before we do that, I want to talk about some vocab here that I want you to write down, or terms. If I say a to the n, that just stands for a term. Let's reword that. A to the n, that stands for the nth term. Everyone write this down on the front of your notes. Stands for the nth term. So for example, if I say a to the 1, or a1, what term is that?
The 1th term.
The first term, yes, first term. Okay, if I did all the way from a to the 35, what term is that? The 35th term. Are we seeing a pattern here? Okay, whatever that n value is, that's the number of the sequence. So if I ask you this, what term is this number 21? What term is that?
21th term.
That is the 6th term, right? Where did you get that from? Yeah, so this would be A1, A2, A3, A4, A5. This would be A6. Okay, so 21 is the A6 term. Okay. Up here, the guy ended up giving the equation for it. Okay. We will talk about this in a second. This is the equation to help you find terms. So if I asked you for the a to the 100th term, would you want to go through and keep adding 4 100 times?
No.
Probably not. That'd be really annoying. What could I do with this formula? Sorry, that's supposed to say 100. What?
Plug it in for x.
You would plug it in for x. You would plug 100 in for x. That would give you your 100th term. Okay? This is what we're going to be talking about creating today. Okay? One other thing I need to talk about for vocab. This was the pattern that kept happening, right? Okay, that's how we know what all of our terms would have been. Okay, this turns into, that is called the D equals. Okay, go ahead and label this as the common difference. Okay, common difference, it's what's happening every time in the sequence. So between all the terms, we knew we were adding 4. That is our common difference. When you hear the term arithmetic sequence, okay, we already talked about a sequence. That's a sequence of events that's happening. What does arithmetic mean, or arithmetic?
Math.
Math, specifically with numbers. Okay, arithmetic is numbers. What is the other type of sequence? For arithmetic is numbers. The other one starts with a G.
Arithmetic.
Geographic.
Close. Geometric. What do you think a geometric sequence is?
Using letters. Or shapes.
Could be shapes. Okay, it's anything but numbers. Okay, it's just seeing patterns through other things. Okay, so we're mostly going to be working with arithmetic sequences with numbers. Okay. So here, what's happening from 4 to 7? Add 3, 7 to 10. 3, 10 to 13. 3, 13 to 16. I'm going to ask you this. What is our A1? A1, that means our first term in the sequence was 4. What is our common difference? 3. Good. I want you to do the same thing on example 1A. I want you to tell me what is my A1 and what is my D. Go. On example 1A, tell me what my A1 is and tell me what D is. Go ahead and try B also. On A, first of all, what's A1?
25.
25. What does that A1 stand for? How do I know it's 25?
That's first term.
First term in the sequence. Okay, so whatever term is listed first, that's your A1. How do I find D?
How much is skipping?
How much it's skipping, what the pattern is, okay? How do I go from 25 to 20? Minus 5, yep. 20 to 15? Minus 5, 15 to 10. Minus 5. So what is our common difference? Negative 5. Yep, don't just put 5. We need to know if it's going negative or if we're going positive. Okay, this one was a negative 5. That's all I needed there. Let's look at B. Okay, what is my A1? A1 is 2, because that's my first term listed. What about the difference? What'd you say? Not a clue is what you said? How do I get from 2 to 4? Add 2. Can I assume all of these are add 2? No. What about 4 to 7? 3. 7 to 12. 12 to 13. What do you notice? Is there a pattern? No. So is there a common difference? No. Okay, it is okay to have no common difference. Okay, so is that list of numbers, is that a sequence? If there's no common difference? No, that's not a sequence. Yep. Good. All right. Next thing here, off to the side of example 2, we're going to write a definition. So I'll go ahead and label this recursive definition. Okay, this is the first of 2 definitions we're going to talk about today. Okay, so the recursive definition sets up a piecewise function. What is a piecewise function from last week? Do you remember? How many functions are we dealing with?
3.
We could deal with 3, but we're at least dealing with 2 or more. Okay, so a recursive definition looks like this. It says an equals, and then we set up our piecewise function here. Okay, go ahead and write this down underneath your definition. So yes, this is a definition, but it's kind of giving you a formula to go off of. Okay, so a to the n equals, when we have a1, what is our n value? When we have a1, our n value is 1. So, oh man, I messed that up. A to the 1 when n equals 1. There we go. For any other term in the sequence, that a to the n minus 1, we add the difference, and that is for all the other n values. So n greater than 1. That is our recursive formula. Okay, that is what we are going to use to help. 2 things that we need to know. 2 important things. We need to know A1, and we need to know the common difference. Those are the 2 things we need to know in order to use this definition. Something I want to talk about here, when we start to use this formula, you will never plug in a number for this right here. You will never plug in a number for that. That is just a placeholder for what term you are looking for. Okay, but this formula here stands for all the terms in the sequence. Okay, let's go ahead and look at this one here. We're going to be looking at A here. What is my A1? 103. Okay, what else do we need to know? The difference, common difference. How do I find that? I find out what is in between, right? So how do I get from 103 to 99? Subtract 4. Can I assume all of these are 4? No. 99 to 95? Yep. 95 to 91? 91 to 87? Negative 4. So what is my common difference? Negative 4. Can I put positive 4? No. Gotta have the negative. So now we're going to use that formula that you had. So that was our a to the n, where a1 when n equals 1, and a to the n minus 1 plus d for all n values greater than 1. So do we have the 2 things that we need?
Yes.
Yes, they're right here. We're just going to plug them into where they go in the formula. Okay, so this turns into a to the n equals, well, what is a1? 103. So that goes in for A1, and that's when n equals 1. Do I plug anything in for this?
No.
No, that's a to the n minus 1. What do I put in for plus d? Yep, minus 4 for all the n values greater than 1. So all I did there was I took the sequence and I found my a1 and I found my common difference. Okay, and then I just plugged it in to where they go in the recursive formula. All right, here, looking at this recursive definition. First of all, how do I know that's in recursive form? How many functions are we looking at? We're looking at 2, right? So here, I just want to test you a little bit. What is my A1? How do you know?
Because it's the first one right down.
Right, if n equals 1, our A1 is 3. What is my common difference?
0.5.
It is 0.5. Okay, so you can get your A1 and your difference from that recursive definition. Okay? All right. Let's talk about our last definition for today. It's called the explicit definition. Okay. The explicit definition and the recursive definition go hand in hand. You can take these notes off to the side again. Yep. They go hand in hand. They work together. So this explicit definition is a to the n equals a1 plus d times n minus 1. Again, what are the 2 things you need to know? Yep, need to know A1 and D. If you have both of those things, you're good to go. Okay? So here, I want to go from here. You do not have to write this down because it's not in your notes yet. But here, what is my A1?
16.
A1 is 16. What is my common difference? Yeah, do I need the negative?
Yes.
Yes. Okay, when I have both of those things, I can write my explicit definition. So I have a to the n equals a1 plus d times n minus 1. Plug in what we know. What is a1?
Negative. No, 16.
16 d minus 3 times n minus 1. This right here is my recursive definition. Or sorry, explicit definition. That's the only thing you have to do. Yep, you don't have to go any farther there. Okay? On this one, this is your example 3. I want you to do part A. It wants you to go from the recursive and write the explicit definition, like we just did. Okay, and then part B, it wants you to go from the explicit to the recursive. Go. Let's go over these here. On A, it gives you the recursive. I want to go to the explicit. Okay. On A, what is my A1? What's A1? 45. What is the common difference? Negative 2. So what A wants us to do is it wants us to write it in the explicit form. So this is our explicit definition. We are just plugging in what we know. Okay. So if I plug it in, what is A1? 45 minus 2. Right, and then I just keep that n minus 1. Okay, this is your part A. We just went from the recursive to the explicit. Okay, part B, it gives us the explicit. Now it wants us to write it in recursive form. So now we're going back to this. Okay, so again, what are the 2 things that we need? A1 and the difference. What is A1?
1.
Yep, A1 this time is 1. What is our difference? 7. Good. So then we just plug it in for what we know. So AN equals, A1 is, careful.
No, 1.
A1 is 1 when n equals 1. And then a to the n minus 1, what's the difference?
Plus 7.
Plus 7 for n greater than 1. Okay, we were just practicing writing the definitions there. Some things I'm going to have you change real quick. says Samantha is training for a race. The distances of her training runs form an arithmetic sequence. She runs 1 mile the first day, and change this 2 miles. She runs 43 miles the 7th day. Okay, go ahead and change that on your example 4. Okay, on part A, it wants us to write the explicit definition for the sequence. Again, what are the 2 things we need to know in order to do that?
The A1 and the difference.
A1 and the difference. Okay, let's see what we can get. Do we know what A1 is?
Yes.
First of all, what does A1 mean?
I don't know.
First term. What would our first term be in this case? 1. Why?
Because it's the first number.
Right. She ran 1 mile the first day. So the first day is our first term. So we know our A1 is 1 for that 1 mile. Do we know what the difference is?
Yeah, it's 43.
43 tells us how far she ran on the 7th day. But do we know what's happening every day? Or how much more she's running every day? We don't. Okay, so really we are trying to find what our distance is. Okay, the other information they gave us, though, do you agree is the 7th day? Okay, so I can write that as A to the 7th. How many miles did she run on the 7th day? 43. Okay, now they said write the explicit definition. So here's our explicit definition, and I want you to write this down. Our explicit definition was this. Can we somehow use this to help us find the difference? Say yes.
Yes.
We can, right? If there's a variable in there, we can plug in things that we know to help us out. Okay? I want us to use this right here. We know what A to the 7th is. So if I know that, we know A7 equals, well, what's A1? 1. Plus, do we know what the difference is? Nope. Do we know what N is?
Yes, 7.
Yes, why is it 7?
Because that's how long it works.
Yeah, we're talking about the 7th term, right? Okay, so we have 7 minus 1. This is what I should have done earlier. Okay, do we know what A to the 7th is?
43.
It's 43, so I'm going to put 43 in right here. This just turned into an algebra problem for you that we can solve. Okay, but to be careful, we have to follow order of operations. Okay, so what do we have to do first? Parentheses, what's 7 minus 1?
6.
Yep, so this just turned into 6D. How do I get D by itself? How do I solve?
Make it subtract 1.
Yeah, we need to subtract 1 first. Good. So I get 42 equals 6D. What do I do from here? Divide by 6. So what do we end up getting for D?
Um,
7. So we just found over here D equals 7. Is that what A wanted?
Yes. No.
It's a part of it, right? It wanted the full definition. So now that we know that, we can write the full definition. Okay, so our full definition is A to the N equals, what's A1?
1.
1 plus
7.
7 times
43. No.
N minus 1.
just that N minus 1. Yep, because this part we are just filling in the formula. And what are the 2 things you need to know for the formula?
A1 and D.
A1 and D. And once you have those, you can plug them into their spots. Okay, that was part A. Part B wants to know how far does she run on day 19. How can we use this to help us? Do we want to add 7 19 times? No. Could you do that?
Yes.
Yes, but that's really long and overdone. Okay. How can we use this formula here to help us know how far she ran on day 19? Do you agree day 19 means A to the 19th?
Yeah.
Okay, how can we use that?
We can plug that in for A. N.
Right, what's our N value then?
19.
19. So we can plug this in. We know day 19. Plug that in for N. This is your part B. So now it's just a matter of evaluating that right side. So we get 1 plus 7 times 19 minus 1.
Parentheses.
Yep, which is 18. So what do I need to do next?
Add 1 and 7.
Order of operations tells us we need to multiply first. Yep, so this is going to give us 1 plus 126. Now I can add them together to get 127.
So 19 is 127.
Yes, part B is 127. Okay. Now, I'm going to give you one more problem. What about, you don't have to do it, but what if I asked you to find a to the 65?
Plug it into n.
What do you plug into n?
65.
65. Awesome. Okay, here's what I want you to do. Go ahead and flip to the back of your notes. We're going to do the other half tomorrow. What I want you to do here, circle number 6. Okay, and what I have for you to do is on the board up there for number 6. Okay, you're going to do 4 different things for it. You're going to do, for the first one, you're going to write the next 2 terms. And then you're going to write the recursive definition, and then write the explicit, and then find a to the 50. Okay, you're going to do all 4 of those things for number 6. Okay, and you can use that whole space on the backside. Okay.